Alright, so yesterday we looked at solving systems of equations by graphing. Today we want to use the method of substitution to do the same thing. We're going to look at two linear equations, find out where they cross, but this time we're not going to go through that tedious process of graphing. This time we're just going to substitute one variable in for the other algebraically. So let's say we had a system of equations, y equals 3x and x plus 2y equals negative 21. Now, you might notice that since we're saying y is equal to 3x, I can take this 3x and plug it in for this y, since they are equivalent. So I'm going to do that, and I'm going to get x plus 2 times 3x equals negative 21. Simplify that. X plus 6x equals negative 21. 7x equals negative 21. Divide both sides by 7. We get x equals negative 3. Now that I know x, I can go ahead and solve for y, knowing that y equals 3x given up here. So therefore y equals 3 times negative 3. So y equals negative 9. I have a point at negative 3 and negative 9. Let's go ahead and try another example. What if we had x plus 5y equals negative 3, and we had 3x minus 2y equals 8. This one is a little more involved, as we have to solve for one of the variables. I look for something without a coefficient first to solve for, so I don't have to divide anything and end up with fractions. So I'm going to go ahead and solve this top equation for x by subtracting 5y from each side. I'll get x equals negative 3 minus 5y. So now, knowing that this is x, I can put it in for this x. So I'll get 3 times negative 3 minus 5y minus 2y equals 8. So therefore we'll distribute. We get negative 9 minus 15y minus 2y equals 8. I'll add 9 to both sides and combine my terms. So I get negative 17y equals positive 17. Divide both sides by negative 17. I get y equals negative 1. I'm going to go ahead and put that into my equation up here to figure out what x is. X is negative 3 minus 5y, or 5 times negative 1. That's going to give us negative 3 plus 5, or positive 2 for x. So I have a point at 2, negative 1. We could have the case where something like this: 6x minus 2y equals negative 4. Y equals 3x plus 2. I'm going to go ahead and put this expression in for my y, since they are equivalent. 6x minus 2 times 3x plus 2 equals negative 4. So 6x minus, we'll distribute, 6x minus 4, don't forget to distribute that negative sign, equals negative 4. Add 4 to both sides. We get 6x minus 6x, or 0, equals negative 4 plus 4, or 0. We know this to be true, so this means these two are the same line, or they have an infinite number of solutions. Another case, you could end up with something that's not true, like 6 equals 3. for your final answer, this means that you have no solution. If you get a false answer, that means that those two lines never cross. So that concludes our lesson on substitution.